In this video, we have a trig equation that we want to solve. And we'll begin by bringing all of the terms to one side of the equation. And it doesn't matter if you want to bring everything to the left or everything to the right. Either way is fine. I'm going to choose to subtract cosine of x from both sides, which will leave me with 0 is equal to 2 sine of x times cosine of x minus cosine of x. Now it's worth noting that we have two terms here on the right-hand side of this equation, and they both have a common factor. The greatest common factor is cosine of x, so we are going to use greatest common factor, factoring basically, GCF factoring, and we'll factor out a cosine of x. We'll be left with the quantity 2 sine of x minus 1. Now, since this equation is equal to 0 and we have a product on the right-hand side, we know that one of these two factors must equal 0. That's using the zero product property. So we'll set each of these factors equal to 0. And this gives us two somewhat simpler trig equations to solve. So we'll start on the left. Cosine of x equals 0. Remember, x represents an angle in this case, so we're thinking about our unit circle. And on the unit circle, we're wondering what angle has a cosine value of 0. And that would happen here at pi halves. It would also happen down here at 3 pi halves. But then remember, we could continue going around the unit circle, and as long as we ended here, where we have pi halves, or around again and ended down here where it used to be 3 pi halves, we would continue to get larger and larger angles that also have a cosine value of 0. And because the directions on this problem simply say to solve, they don't restrict us between 0 and 2 pi. That means we have to give all of the solutions, and in this case there will be an infinite number of solutions. So let's start with pi halves. To travel from pi halves to 3 pi halves, we would add 180 degrees, which would be an angle of pi. And then to travel from 3 pi halves back up to the next angle, which has a cosine value of 0, which would be 5 pi halves, notice we would add another 180 degrees, which would be another angle of pi radians. So the best way to write our entire solution set here, x can be every angle, starting at pi halves, and adding multiples of pi. So we can write that as pi times k, where k is an integer. I've also seen some authors and textbooks or teachers use pi times n here instead of k, and of course that's perfectly acceptable. So this is the first part of my solution set, pi halves plus pi k, and that will give us all of the angles that have a cosine value of 0. But now we still need to solve the second part of this equation, 2 sine of x minus 1 equals 0 as well. I'm going to move to a fresh sheet of paper here. So 2 sine of x minus 1 is equal to 0. If we add 1 to both sides and divide by 2, we'll have sine of x is equal to 1/2. So again, we're back on the unit circle, thinking about what angle has a sine value of 1/2. And that would be 30 degrees, or pi 6 radians. So if I were here at pi 6 radians, I know the sine of pi 6 is 1/2. But notice that 1/2 is a positive value. And so sine is positive not only here in the first quadrant, but is also positive here in the second quadrant, which means we have another angle that also has a sine value of 1/2. So my reference angle, essentially, my reference angle is pi 6. So if I draw an angle in the second quadrant that has a reference angle here of pi 6, then I'm interested in the angle here, that angle that I have drawn in orange, that would have a sine value also of 1/2. And so I like to work backwards from 180 degrees or pi radians here. So since I'm dealing with a reference angle that is in terms of it is a sixth, pi sixths, then pi is the same as 6 pi sixths. Therefore, if I work backwards, the angle that I'm interested in is 1/6 or 1 pi sixth less. That means that I'm interested in the angle 5 pi sixths. So between 0 and 2 pi, initially my two angles would be pi sixths and 5 pi sixths. But just as before, we recognize that we have to continue going around the circle to get all of the possible solutions. So we would start with, in this case, the angle of pi sixths. Now last time we only added pi times k, but we'll notice in this case we can't add pi because that would put us in the wrong quadrant. So we're going to have to go all the way around the circle. In other words, we're going to have to add 2 pi k, multiples of 2 pi. And then likewise, the same is true for the angle 5 pi sixths here, that I'd have to add a full 2 pi and go all the way around the unit circle one time to get the next angle that has a sine value of 1/2. So that would be 5 pi sixths plus multiples of 2 pi, so 2 pi k. And then I will go ahead and go back and grab my solutions from before, from here. That was pi halves plus pi k. So pi halves plus pi k. And for all of these, we're saying k is an integer. So where k is an integer, this would give me my entire solution set. So we're looking at this being my solution, all solutions to the trig equation given.